start doing the problem, and 5 minutes, at least one equation should come out, or we should have the two equations that would probably result in the creation of this model. So you'll get something like this. You'll get basically B dash is equal to A B plus B. This is the model that we are looking for. So what we can do is that we can assume that there is a current here which is I1, and there is a current here which is I2, and you can basically apply the nodal law from network analysis that you people must have studied. So there is one node here, and there is one node here. So let me call this say node 1, and this node 2. So basically the voltage at node 1 is V1 and the voltage at node 2 is V2. So at node 1 the voltage is V1, at node 2 the voltage is V2. At this point here the voltage is U basically. So if you see this node, then do you people know nodal analysis, how it is done? Do you have any idea?
So we did study it for semester.
Or somehow the idea is not clear. Oh, you don't remember it perhaps. Okay, anyways, doesn't matter. So nodal analysis is something like this. So let's look at this node. So what we do is that we basically look at the current flow about this node. So if you look at node N1, so if this is N1, then forget all the components there. Some current is coming from this side, which is basically this current going here, and that current is bifurcating into some current here and some current. So this is basically your KCL. So the question is that we would have to write, suppose I call this current as I1, and I call this current as I2, and I call this current as I3. So I can just write at this node that I1 is equal to I2 plus I3. That's what I can write. Now what is I1? I1 is the current that is flowing here. Now the current is obviously going to be the potential difference across the two nodes of that resistor divided by the resistor itself. So what I get is the current flow is from this point to this point. So I can say that I1 is nothing but V1 minus U divided by R1. So that's your I1. Then your I2 has been taken as small I1 in this problem. I've already given it to you. Then if you look at your I3, then your I3 is basically going to be so I'm so sorry, so the current flows from here to here, so this is going to be U minus V1. So let me just correct it, because the current will flow from a higher potential to a lower potential, so this would be U minus V1. And when the current is flowing from this point to this point, here the voltage at N1 is V1, the voltage at N2 is V2, so this is going to be basically V1 minus V2 over R2. So you get an equation which says U minus V1 over R1 is equal to I1 plus V1 minus V2 over R2 from this. Okay, so but now if you look at this equation, then because I've taken state variables as V1 and V2, then I need to do something to this I1 so that it is represented in terms of state variables. And also if you look at this equation, I do not have a differential term. I don't have either dv1 by dt or dv2 by dt, because that is something that should come in the equation for me to write state variable. But I also know that I1 is nothing but C1 dv1 by dt. So this is the governing equation for a capacitor. So I put it here. So I get Q minus V1 divided by R1 is equal to C1 dv1 by dt plus E1 minus V2 by R2. So you can just take things on one side, and this becomes by R1 plus V2 minus V1 by R2. I just took it this side and I interchanged the signs. So you get dv1 by dt equal to so minus 1 upon C, and just correct me if I'm wrong, 1 upon R1 plus 1 upon R2 V1 plus 1 upon C R2 V2 plus 1 upon R1 C1 U. So I get the first equation, which is in terms of state variable V1 dash now. So you can just write, this is the V1 dash. So you got first equation. So one is done. Now similarly, if you look at this equation, then the second node is this node here. So it's simple. For this node, what is the scenario? The scenario is that there is some current coming like this, and then it is going like this. So this is your N2. Something comes here and it just goes here. So they're basically the same things. So whatever is coming is going out. So you could just say, so in this case, basically what is happening is that your V1 minus V2 divided by R2. So you have V1 minus V2 divided by R2 is basically same as I2. That is what it is. So this was your I2, and this is the current which is coming on this side, which is V1 minus V2. And they are just flowing because they are in series, the resistor and the capacitor. So it's the same current, and this becomes equal to C2 dV2 by dt. And so you get an equation which is, dV2 and dt is 1 upon, I should have written C1 and C1. So this becomes C2 R2 times V1 minus 1 upon C2 R2 times V2. So I get the second equation, and once I have them, I can simply write them in terms of that equation. V dash is equal to AV plus BV. You can just combine them and you will get the expression for A, and you will get the expression for B. So that's how sometimes it doesn't have to be that the currents in the circuit have to be the state variables. You could have, so basically the state variables are chosen in such a way that in the equations for a circuit, you get a differential of those state variables. If you would have chosen currents as the state variables, well, because they are also time varying, one could say that use them. But then in this problem here, you cannot formulate any equation in which the current is also changing with respect to time. Well, differential of current is something that you di by dt or those kind of terms cannot be created, and therefore the idea is that we use voltages. So it kind of gives you the flexibility to choose state variables. Okay, so now, so this is basically the input equation. Suppose I say uh, that there is an output also. We are tapping an output from this equation. So let me just rewrite this again, the circuit diagram. So in all the problems till now, we are just writing equations of the form x dot is equal to ax plus b. But there is another equation which is y dot is equal to cx plus du. So let's say that you have the resistor R1 here, you have resistor R2 here, you have C1, you have C2, you have UT plus minus, and I say that the output is tapped across this resistor. So your YT is the potential drop across this resistor, or let's say that let's say I1 is, let's say that the current here is the in this branch is the output. We want to see the current R1 as the output. So let me just say IR1 is your output at any. Then my question is that is it so now this is not y dash, this is y only. Sorry. So can you write this kind of an equation? Try to write it and tell me. It should not take you more than a minute. And let me see who will tell me. Kunal, you try to give me an answer to this question. So you have to write y is equal to cx plus du. So I would want an answer from you. कुणाल आंसर आया?
Trying sir. Yes sir, trying sir.
इतना टाइम क्यों लग रहा है कुणाल? Anyone else who's got an answer to this question? What is YT? YT is nothing but the current which is flowing through R1. What is the voltage on this side? It is V1. What is the voltage here? It is V2. What is this current? This current is nothing but U minus V1 by R. So Y is minus 1 upon R1, times V1 plus 1 upon R times U. So that is it. So how do you write this in terms of the state variable? Now I want you to give me the matrix C and D. Should not be difficult. Y is minus 1 upon R1, 0. You'll have V1, you'll have V2 plus 1 upon R1 into U. That's it. That's the answer to this question. So this is a question in which you had to choose your state variables yourself and you had to solve it. Let's look at another question in which we'll probably get a state specification. Next problem. Let's say so here is your UT, this is the input. So this is L1, this is L2, this is C, and this is R2. Okay, so now your UT is the input and this is the circuit. Now if I ask you what would be the state variables that you'll choose, then what will that be? Can you tell me what state variables you choose?
Inductors.
Yeah, I'm sorry?
Sir, voltages across the inductors.
Voltages across the inductors. No.
Sir, current across.
Yes. Ishan, if you look at it, the voltage across an inductor is some L times di by dt. So for inductors, the quantities that come in differential terms is di by dt. So that means that if I say, if I say that, you can just probably do like this. You can say that the current in this branch is I1. So one state variable is your I1 because you can form a differential of this state variable. So this is the first state variable. Then let's say that the current in this is I2. So you can form a state variable I2 because you can write that VL2 is equal to L2 di2 by dt. So you get that differential also. So the second state variable is I2. And if you look at the capacitor, then the state variable can be Vc, which is the capacitor voltage. So that is how you decide. So the idea to give this example, and I would want you people to solve it right now. And the idea is basically to, if not given state variables, how do you identify what will be the state variables? So for electrical circuits, there is a thumb rule. The thumb rule is that if you see inductors in the circuit, then the current through the inductors will be a state variable because you can formulate those di by dt terms. And if you have capacitors in the circuit, then by thumb rule, the voltage across the capacitor will be the state variable because you can formulate dv by dt terms. So those are very important when we create state space approach. So now solve this problem. Let the current here be I3. So now I would want you people to give me the state space approach. It's 9:55. You should be able to give me equations by 10 o'clock. Start doing the problem, please. And you will get such problems in the exam. So if you're just sitting there waiting for me to solve it, that's not going to help you in the exams. So please try the problem genuinely and honestly and get me an answer, please. Can anybody tell me the answers? नवरत्न कुछ इक्वेशंस बनी? हो जाना चाहिए अब तक. So if you look at the problem, let's take this loop here. And we start from this point. We're starting from this point. We go up to this point. So let me just call it A, B, C, D, E. So we are going A, B, C, D, A. So equation is ut minus I1 R1 minus L1 di by dt minus Vc equal. So basically this is the plus point of Vc and this is the minus point of Vc, so that's all minus V. So if I write it, so di1 by dt is minus R1 I1 minus Vc plus Ut. So that gives me basically that di1 by dt is minus r1 l1 I1 minus vc by l1 plus u by l1. So this is the first equation in terms of state variables and input. So this is not 4, this is L1. Let me just... So this is L1, L1. Okay, this is the first equation. Then we take this loop here, and this loop is going to be... So we go to CE FDC. FDC. So if we look at it, then we have minus L2 di2 by dt. So minus L2 di2 by dt. Then minus I2 R2 minus I2 R2 and plus VC. So plus VC equals 0. So that gives you L2 di2 by dt is equal to minus R2 I2 plus VC. So di2 over dt is minus R2 over L2 times I2 VC. This is the second equation. So this was the first equation, this one. Because we have 3 state variables, we should have 3 equations. So this is your second equation. And can anybody tell me what will be the third equation? How will I get the third equation? Look at the circuit.
Sir, A, B, C, E, F, D, A.
You want to take the bigger. You want to take the bigger one. You know that there is a better way to do it, and it's a simpler way. But if
So
you
the
take the
I1 minus I2
I1
equals to
equal to
C into
I2
dVC by dt.
yes, that is how. Kashish, right? Thank you. So
Yes.
Ishan, the problem with the bigger loop is that if you take the bigger loop, you will get L1 and L2 in the equation, but this capacitor will not come into the picture, and you will not be able to write dVc by dt. You need to express an equation in terms of dVc by dt also, because you have one equation in terms of di1 by dt, because this is a state variable. Then you have second equation in terms of di2 by dt. So you have this equation. So now you want an equation which is dVc by dt, and if you take the bigger loop, you're never going to get it. Of course, you can take the bigger loop, but the idea is not to solve the circuit. The idea is to represent it in form of a state space model. So that's why we are not going to do that, and we are going to write it like this. So if you look at this node, then you can see that the incoming current is I1 and the outgoing currents are I2 and I3. So I just draw it here. So you have basically this. So you have I1 coming here, you have I2 going here, and you have I3 going here. So simply at this node, the equation that gets satisfied is this. Now I1 and I2 themselves are state variables, so we don't really need to worry too much. We just write it like this, and we write it I3. Now I3 is the current which flows across the capacitor, so that is C dVc by dt. So now from here you get the equations that dVc by dt is basically 1 upon C I1 minus 1 upon C I2. So now all the 3 state variables have been written in form of equations, and you can combine them together to give you a model of type x dash is equal to ax. So I could have, I can also state one of the currents or voltages as the output, and you may have to write the output equation, but it should be simple. Now, I think there is one thing that I should have probably discussed a little earlier, because I'm feeling that uh, there is some confusion about the sign conventions when we apply currents and voltages. So let me just talk about it a little bit, so that when a circuit is given, at least you are able to apply KVL, KCL, because maybe you don't remember network analysis, or you don't remember circuit and system. So just for clarity, I'm writing something here, and this would be the sign convention that you can follow. Suppose this is a battery, and this point is A and this point is B. Then this is the positive side of the battery, and this is the negative side of the battery. So if you are in a circuit and you are moving in this direction, this is the movement. This is the direction of movement. So this EMF is going to be taken as minus E. Basically, that's the sign convention. You could have taken it plus E also, but this is generally what I adopt, and many of the books also adopted. So that means that now suppose if you have a voltage which is like this, A and B, and this is the direction of the movement. Which is minus and plus. So you're entering into minus, and then you're exiting from plus. So I like to take it as plus. So you can always argue the opposite way also, but this is generally what I do. Just a second. Yeah. So when it comes to a resistor, I follow this. So suppose you are at A and B, and the current flows in the resistor in this direction. Suppose this is the current that flows. Then if I move in this direction, in the same direction of the current, then the potential drop is I into R. If the current is flowing in the same direction as my movement, I will take it as minus IR. Similarly, or oppositely I should say, sorry. Suppose the current is flowing like this, A and B, and I move like this. Then I take it as plus R. So the current is opposite to your direction of movement, I would take it as plus IR. And then it's similar for an inductor and a capacitor. So A and B, and this is L, and this is I, and if I'm moving in this direction, then I will call it as minus L di by dt. That is the potential drop is going to be minus here. And if you have a current A and B and L, the current is going like this, but you are moving in this direction, then I will take it as plus LD. So that is basically what it is. And for a capacitor, it's a voltage, and you can formulate similar law. So just remember this, and I think probably if you follow, you're free to follow whatever sign convention you do, but the idea is that you should get the answer basically. Okay, so just maybe pay attention to it a little bit, and I think probably things will sort itself out. Okay, so now let's look at another problem. Kind of similar to the previous one, so just for practice, maybe you can write it. Let's see. Oh, I think it's going to be similar. Wait a minute. Also something to written. Okay, let's do this. Okay, so we're like going to a different set of problems. Suppose I say that you have an equation x dash is equal to ax plus b. Okay, and I say that there is only one state variable x. So this equation becomes dx by dt is equal to ax plus b. Then I say represent this using a block diagram. How will you do it? Represent this using a block diagram. How will you do it?
So we will take Laplace transform of it first of all.
Yeah, so make it and tell me just by looking at it. There's no need to take a Laplace or anything. I mean, just write A and B in the blocks, and there is no need to take a Laplace. Just in the if you had to make a block diagram or in time domain, then what will be? Of course, I mean, if you want to calculate transfer functions and all, then you have to take a Laplace. But if I just say this is the figure and this is the input, which is basically ut, and you have an output, then you can use A and B as blocks, and then how do you make it? So u is the input, x is the output. So what do you do? And so basically you need a block which should work as an integrator or differentiator. So that's the hint to get this. It's a simple thing. I don't know why it's taking you so much time. The input is u, right? U. Then the net result is bu. So you get something which is b here. It is adding something. So you get a adder. The output is x, right? So for this, the end result is x. So x gets added to bu so multiply it with a. So this gets added. What you get is x dot, which is dx by dt. Then you just simply, if you have x dot and you need x, then this block will have an integrator, and that's it. This is the block diagram in time domain. So this is an integrator. This is an integrator. Now, suppose I say you have dx by dt is equal to ax plus bu, and y is equal to cx plus du. Make one block diagram for both these things. Getting satisfied. Try to do that. How will that block diagram look? Can anybody give an idea? Maybe धीरेन्द्र. कैसा बनेगा इसका ब्लॉक डायग्राम धीरेन्द्र? धीरेन्द्र है या सो गया या भाग गया?
हूँ सर, ट्राई कर रहा हूँ.
बताओ कैसे करोगे? इतना टाइम लगना नहीं चाहिए. पेपर में आएगा तो कैसे करोगे?
सर एक बार क्वेश्चन रिपीट करना।
कौन बोल रहे हैं?
नवरत्न
हाँ नवरत्न बताओ।
सर क्वेश्चन रिपीट करना एक बार, मेरे समझ में आया कि किसका ब्लॉक डायग्राम है।
आवाज नहीं आ रही आपकी, क्लियर नहीं आती आवाज।
Sir, can you repeat the question?
The question is, you need to create a block diagram that would block diagram that would implement both these equations. That is what the question is.
सर सेम सर सेम जो क्वेश्चन जो पहले था उसमें एक ब्रांच और बन जाएगी जिसमें डी और सी एक साथ कंपैरेटर में ऐड होकर वाई आ जाए।
हाँ बस, that's it. It's simple. So you have, just because I'm giving a question doesn't mean that it has to be a tough one, So this is what it is. You have x here. It gets added. You get a here. Then when you add, you get x dash. Then you have an integrator. And you get x. Then if you look at y is x times c. So basically, is your x, you multiply it by c, then you have u getting multiplied by d, so u gets multiplied by d. That's it. This is the block diagram for this. Okay, this is the block diagram in time domain. Everything is in t. But if you were to make a block diagram in frequency domain, which is generally done to get transfer functions, so then, of course, as Kashish said, that you have some equation which is going to be ax du. So then you take the Laplace. So this becomes xs. This becomes axs. So I'm assuming that the initial condition is 0, but if you want to add it, then you can add it here. And then, you have to then it depends whether you want to show a feedback or you don't want to show a feedback. So then based on that you can create it. So you can either bring all the x's on this side, and then that will be basically in terms of this 0 input and a time domain input, you can write. So this will be x's is going to be basically 1 minus a, sorry, s minus a, 0 plus d is going to be b s minus a dx. This is 0 s. So you can also see that this provides us a way to solve the problem. Now suppose this input had a particular form. Let's say that this input was a delta input, so us would be 1, and then xs is here s minus a, s minus a. If you remember Laplace transform, then you should also remember that inverse Laplace transform will take it to the e to the power at term. So you get a time domain representation and you can solve the problem using Laplace domain as well. So now you can just kind of represent this using a block diagram. So so the kind of problems that you can expect in state space variables, some of the problems are going to be very simple in the sense that you will just have to identify what are the quantities that could be state variables. I don't think that should be a problem now. The key to identify state variables is dependent upon the components that are present in the circuit, and since the electrical circuits will either have a R or an L and a C, so if there is R and C, then voltage across the capacitor is going to be the state variable. If you have R and L, then it is the current across the inductor that will be a state variable. If you have a circuit that has R, L and C, then the current in the inductor and the voltage across the capacitor are going to be state variables. In any circuit, whether it's an electrical circuit or it's a mechanical circuit, you will take those quantities as state variables whose derivatives with respect to time can be incorporated in the equations. So these are some kind of problems that can come. Then some kind of problems that can come is that maybe I will give you a state space model, and then you'll have to create a block diagram, or I'll give you a block diagram and you have to give me the state space model. So those kind of problems are there as solved numericals in 2.0. Just try to go through them. Then the other kind of problems could be that I can give you some matrix manipulations. Like suppose if you have A as a matrix and then I write X in terms of maybe some A1 X1, then I would say what is the composite matrix. So, and what is the transform matrix, or what is the transform solution. So those kind of transformations can come in which you have to do simple matrix manipulations. So most of the problems that are going to come in the exams, almost 60% of the problems are going to be straightforward. Then I'll give about 15 to 20% of the problems that will involve some bit of rigor, and then the remaining problems that will stay, they are going to be the problems that will involve a deeper level of application of concepts such as that. So on and all, the paper should be easy. We have one more class in which we are going to look into numericals of signal flow graphs and block diagrams, and that will probably, so basically you have signal flow graphs to do, you have block diagrams to do, and you should be able to create state space models either using block diagrams or circuits or differential equations. So these are the basic things that you really need to do. Alright, and the paper is going to be, I think control systems paper is probably the last paper, and it will be for 1 hour. I would want to take a test for 20 marks. Okay, so I'm going to put up most of the questions are, I think the questions are going to be MCQ questions, but you would have to solve to get the answer. It will not be very straightforward. So that you'll have to see. But most of the questions are going to be MCQs. All the questions are going to be MCQs, but you'll have to solve them basically. All right. Okay, then I'll see you tomorrow. Tomorrow's class we'll have at 9. Okay. So we'll meet at 9 o'clock tomorrow. Right? Okay. Thank you. If there is no question, then we end the class.